Hello everyone. This is your second lesson on Circles 2, which is the application lesson, so 11.2a. So this is going to apply things that we did last lesson to do with semicircles and sectors and apply them to more real life scenarios. Now this is the first question in, or the first example should I say, in the book. And we're told that this is an equilateral triangle and we've got a sector here and a sector here. Right. Now, we're told a really important piece of information, I've already written them on here, is that the triangle is equilateral, because we'll need to know the angles to be able to deal with the sectors. So what we're going to look at first is we're going to use the formula for arc length that we saw last lesson to work out this length and this length here. Right, so arc length, we should know, is a part of, or an arc is a part of the circumference, so theta divided by 360 degrees times by pi times by d. So now we're just going to look at this part here. So we know theta is going to be 60 degrees. So 60 out of 360 degrees times by pi times by the diameter. Well, again, we're just looking at this bit. The diameter is going to be 120 centimetres, the radius is going to be 120 centimetres, therefore the diameter is 240 centimetres. And all I'm going to do now is stick that in my calculator, so 60 over 360 times pi times 240, that gives me 40 pi, not sure if you can see that on there, but if not, to one decimal place is going to be 125 point. Actually, I'm not going to round it yet, because that will make my answer less accurate. But so that's everything that appears on my calculator. So that arc length there, so I know what I've just worked out is that this length here, from A all the way around to C, is 125.66 and so on. Now, we can do exactly the same thing using this sector. But we can use a bit of a trick. Because this is an equilateral triangle, that sector, that one, is going to be identical to that one. Now that only works because it's an equilateral triangle. In other words, the angle in the sector there is the same as the angle in that sector there. So I know that this bit is the same as this bit. Right. So the perimeter is going to be the pink bit, which is going to be 125.6637061. The blue bit, so plus 125.6637061, identical, plus the 120 centimetres. Now, notice I haven't actually cancelled this from, or cleared this from my calculator. If you have, you might need to type it in again, because I'm going to use that answer. I'm going to times that by 2, that'll give me this bit, and then I'm going to add 120. And that gives me a perimeter of 371.3 centimetres to one decimal place. So I've rounded at that point. I haven't rounded earlier on. Now the question, if we look at it carefully, says, Amy says the perimeter of the window is less than 4 metres. Is Amy correct? Well, at the minute we've got it in centimetres. Now we should know a conversion from centimetres to metres. So 1 centimetre is 100 centimetres equals to 1 metre. Okay. So therefore, that 371.3 centimetres is actually the same as 3.71 metres. So I've just divided by 100 to get 3.71 metres. So let's actually answer the question. The question was, is Amy correct that it's less than 4 metres? So yes, Amy was correct. Now it's really common for worded questions, or if it says, or if the question asks you, is somebody correct? You haven't actually answered the question here. You've answered the question there by saying yes or no. So if you need to pause the video at this point, then please do. Now the second example doesn't give you a picture, it just gives you some words. So a circle has a radius of 28 centimetres, the sector has an area of 200 centimetres squared. Calculate the angle to the nearest, there we go, to the nearest degree. Right, so that tells us what we need to round our answer to. Now I'm going to do this a different way to the way it does it in the book. Partly because the method in the book uses something called similarity, which you may or may not have seen yet. So I'm going to do it a different way. So instead of a load of words, I'm just going to write down what I know. So the radius is 28 centimetres. I know the area is 200 centimetres squared. And that's the area of a sector. So I know I'm going to need to use the formula that we saw last lesson, which is theta over 360 degrees times by pi times by the radius squared. So that's the area of a sector. Right. And the theta bit, the angle, that bit there, is what we're trying to work out. Now we know the area is 200. Theta is what we're trying to work out. Pi is just a number, and we know the radius is 28. So we're going to do 28 squared. Right, and we're going to use our calculator quite a bit in this question. Because the way that I'm going to show you how to do this is effectively solving an equation. Right. So what I'm going to do first of all is I'm going to get rid of this divide by 360. So I'm going to times both sides by 360. So that's going to give me theta times pi times 28 squared. And that's going to give me 200 times 360, which is 72,000. You could use your calculator for that. I'm now going to divide by 28 squared. So that would just give me theta times by pi on that side. Now 72,000 divided by 28 squared gives me that fraction. Now I'm going to purposely leave it as a fraction, otherwise my answer won't be as accurate. Now I'm not going to clear my answer there because I'm going to use that again in a minute. And now I'm going to get rid of the pi and I'm going to divide by pi. So again, without clearing my answer, now just press divide. Now notice it uses the answer from the answer before, divided by pi, and that gives me 29.2 3, and so on. Now remember, the question said to the nearest degree. So in other words, that to the nearest whole number. So theta is equal to 29 degrees. And if you look in the book, you get the same answer, but it is done a slightly different way. But that is another way to do it. Right. So all we're doing is we're applying the things that we've already seen, but to a slightly more difficult context and potentially working backwards. Now the work that you have been set looks at this page here. It's exercise 11.2a. Those are the two examples that I've just gone through. Now there are some questions on this page that are extension questions, the ones with stars next to them. So question 5, question 8, and then question 10 at the bottom. So, like I say, they're extension. Don't feel like you have to do those, but please have a go at them. Please make sure that you've had a go at least question 1 to question 4. They look quite complicated, but actually they're just using things that you've already seen and put them into a slightly different context. Okay, and that's it. Right. So please make sure you've got the examples written down in your book, and then have a go.